Alright, so here is the review for Unit 4. This video might be a little bit long, but stick around to the ones you need so you don't need to watch it the whole way through, and the answers are posted as well. So number 1 says, determine the quadrant in which the terminal side of this angle lies. So there's a couple ways to think of this. 9 pi over 5. So if you count by pi's, so like think about this, that well, actually, I'm going to change my mind on that. Let's go ahead. The easiest way to do this is to think to yourself, change it to degrees. So if I have 9 pi over 5 and change this to degrees, I'd multiply by 180 over pi. So what happens there is the pi's cancel, and I do 9 times 180 divided by 5. That turns into 324 degrees. So 324 degrees, I know that 270 is down here, so this must be, and 360 is right there, so this must be in the fourth quadrant. If I were to draw that angle, it would come all the way around to here. Okay? Determine two coterminal angles for this angle, 11 pi over 4. So, 11 pi over 4, first of all, we got to think about, where is 11 pi over 4? So 11 pi over 4, if I count by pi over 4, remember 1 pi over 4, 2 pi over 4, so 45 degrees. 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, 9 pi over 4, 10 pi over 4, 11 pi over 4 is right here. Alright, so 11 pi over 4 is in the exact same place as just normal good old 3 pi over 4. So 3 pi over 4 is going to be one of my answers. And my other answer is going to be to go backwards. Like, what if I go backwards to that same place? So if I go backwards to that same place, that would be 1, 2, 3, 4 pi over 4, 5 pi over 4. So it would be negative 5 pi over 4. And there's many different answers for that, but those are easy too. Alright, so change 240 to radians. So 240 is not one of the ones. Yes, it is. It is on the unit circle, but to go ahead and change it to radians, we take 240 with the formula times pi over 180. So I can see the zeros cancel, so I get 24 pi over 18. These both divide by, let's see, 6. So 24 divided by 6 would turn into 4. 18 divided by 6 is 3, so this is 4 pi over 3. Or you can reduce it using your calculator. Alright, so convert 9 pi over 8 to degrees. So 9 pi over 8 to degrees, so times 180 over pi. 9 pi over 8 is not one that you recognize from the unit circle. The pi's cancel. And so 9 times 180 divided by 8. You get 202.5 degrees. Alright, number 5. Find the reference angles for these things. So 252. So my reference angle is the angle that goes back to the x-axis. So let's see, 252 would be right here before 270. So I need to know how far past 180 is this. So let me just do 252 minus 180. And I get 72 degrees. So this angle right there was 72 degrees. That was the reference angle for that. So 12 pi over 7. So let's count. So let's think about this. 7 pi over 7, so you could change this to degrees if you want, but 7 pi over 7 would reduce down to pi, right? So 7 pi over 7 would put you over here to pi. That's 180. If you keep counting, 14 over 7 would be 2 pi. So 12 over 7 must be around here, and it's everything but 2 pi over 7, because 14 pi over 7 would be the whole way around. So 12 pi over 7 is everything but 2 more pi over 7s to get you to the full 2 pi. So we'll say 2 pi over 7. And another way to think about that is to just take 2 pi and subtract 12 pi over 7. You'll get 2 pi over 7. Alright, so negative 4 pi over 3. So this is one we recognize. Pi over 3 is 60. So let's see, 1 pi over 3, 2 pi over 3, 3 pi over 3. So that would be 4 pi over 3. That would put me right there. So basically what I've done is I've gone 60 degrees past the x-axis. And so my reference angle is 60 degrees, or pi over 3. So I suppose any of these could have been, usually what happens if they give you a question in radians, you answer in radians. Degrees, you do degrees. Alright, so a good old SOHCAHTOA problem here. A surveyor wants to know the height of the Washington Monument. The surveyor stands at a distance of 259 feet away. So 259 feet away, and there's an angle of elevation of 65 degrees. So that's this angle right here. Angle of elevation, if you're looking straight versus you look up that much to get that. And so when I look at this and I want to know this right here, I see this angle, I see the opposite and the adjacent, so I'm doing tangent, right? So tangent of 65 degrees is x over 259. So when I solve for x right there, I get 259 times the tangent of 65. Now, I didn't ask all of the types of questions I could have asked you about SOHCAHTOA, but this turns into 555.4, so let's say about 555 feet. Okay, and on the test it'll have like round to 1 decimal place or round to the nearest foot or something like that. So you can put 555.4 also. All right. So also know how to do the problems where you're missing an angle and you have to you have a couple sides and you're missing an angle, or maybe you have to find the third side by the Pythagorean theorem, things like that. All right. So this is just our unit circle information. Remember, when you're on the unit circle, the cosine is the sine is the y value, the cosine is the x value. So 135. 135 is 45 times 3, right? And so that's one's over here. The coordinate right there is going to be negative radical 2 over 2 and positive radical 2 over 2 from the unit circle. So my cosine is this guy right here. So negative radical 2 over 2. Right? Sine of negative 5 pi over 3. So negative 5 pi over 3. So that's 1 pi over 3, 2 pi over 3, 3 pi over 3. 4 pi over 3, 5 pi over 3. So 5 pi over 3 puts you right around to there. So 5 pi over 3, the, let's see, the coordinates are 1/2 and square root of 3 over 2. So the sine is the y value, so the answer to this question is radical 3 over 2. Tangent of negative 8 pi. So negative 8 pi is 2 pi times 4. So what's happened here is you've gone around backwards once, twice, 3 times, and 4 times. So either way, you're still at this place right here at the place where you have 1, 0. So the tangent is the y over the x. So it's 0 over 1. And 0 over 1 makes 0. So that's your answer. Right, secant of pi over 6. So pi over 6 is right here in the first quadrant. It is radical 3 over 2 and 1/2. The secant is the reverse of the cosine. Since cosine is radical 3 over 2, then the secant will be 2 over radical 3. And if I rationalize that, I get 2 radical 3 over 3. All right, cotangent of 600. So let's see. 600 minus 360 is 240. All right, so I've gone once around and then 240 more. So that's 180 plus 60 more is 240. So I have 60 degrees right here. So 60 degrees means I have basically the same as this coordinate up here, but they're both negative. So negative 1/2 and negative radical 3 over 2. And the cotangent is the, not the y over the x, because that's a tangent, but it's the x over the y. So this will be negative 1/2 over negative radical 3 over 2. So this, the negatives go away. You get 1/2 times 2 over radical 3. Let's cancel. So I get 1 over radical 3, which rationalizes to radical 3 over 3. All right, and the last one over here, cosecant of 5 pi. So let's see, 2 pi and 4 pi, so 5 pi would be over here. That coordinate has a coordinate of negative 1, 0. So the cosecant is the reciprocal of the sine. So the sine is 0, so for the cosecant, I have to put 1 over 0. Well, that is undefined. So you can answer undefined, or you can 0 with a slash through it. All right, so here, I'm given that the cosine is negative 2/5, and the tangent is greater than 0. So this is where you need to remember A, S, T, C. The tangent's greater than 0 here and here, but cosine is negative. So obviously I'm going to be down in this quadrant. So let's just draw a picture. Draw a little triangle down here. Make the cosine 2/5. So 2 and 5. That means that the 2 is a negative one because the hypotenuse never is. Let's figure this out. The hypotenuse is 5 squared, so 25 equals the leg squared, so 4 plus the other guy squared, x squared. So I get x squared equals 21, so x is the square root of 21. And it could be plus or minus, so it is negative square root of 21 because it's going down. All right, so now I have my angle with my picture, and I want to know what's the sine of the angle. Well, the sine of the angle is going to be the opposite over the hypotenuse. So I'm going to answer that the answer to this question is negative radical 21 over 5. All right, number 9, explain why cosecant has asymptotes at these places. Okay, well, remember cosecant is 1 over the sine. Right? And so whenever the sine is 0, then these are going to be places where the cosecant can't exist. Okay, so the sine graph goes like this. It touches 0 at 0, pi, 2 pi, and so forth. So that's just a picture representation of what's going on. But this is more what we need to remember is that that is because at theta equals 0, pi, 2 pi, 3 pi, and so on, sine of those places is equal to 0. And cosecant, cosecant theta equals 1 over sine. So cosecant will be undefined. Right? Because you can't divide by 0. Okay. All right, number 10, write an equation to represent a cosine function that has amplitude of 2, period of pi over 4. So here we go, amplitude 2, cosine. Now the period is pi over 4. So remember, the period goes like this. 2 pi is a normal period, divided by b is supposed to make pi over 4. All right, so let's go ahead and solve this. These cancel. So what I have left then is 2 over b equals 1 over 4. So I'm going to get b equals 8. All right, so I'm going to put that next. I have to move to the right by pi over 2, so I'm going to put x minus pi over 2. And it says down 1, so put a minus 1. Now if you wanted to, you could multiply this 8 through here, but why? Just leave it like this. All right, this guy, arc, all your inverse, cosine, arc, cosine, and tangent, and all that, and sine, and all that. So arc cosine of radical 2 over 2. Remember, arc cosine can have an answer in this area. So if it's positive, it's going to be in the first quadrant. So when is the cosine? What angle has a cosine of radical 2 over 2? Well, that would be pi over 4, 45 degrees. It says answers in radians. All right, arctangent negative radical 3 over 3. So that arctangent can answer here. If it's negative, it's going to be down below. So remember, radical 3 over 3 comes from having, let's see, let me do that over here. It comes from having 1/2 over square root of 3 over 2. And the tangent is the sine over the cosine. So to have this be true, that means that my x value would be radical 3 over 2, my y value is 1/2. So this is the place this happens, because to have the sine over the cosine, when you have this situation, it comes out to radical 3 over 3. When you work it down, we've done that in class a few times, because it comes over to 1 over radical 3, which goes to radical 3 over 3. And this comes from having this situation. So this happens at 30 degrees. So it's going to be a negative 30 degrees. All right, arc sine 1, negative 1. So remember, arc sine can happen from here to here. And so 1, it has to be one of the corners. So the only place where I have a negative in a corner is right here, 0, negative 1. There's the y value is negative 1. So that's at negative pi over 2, negative 90 degrees. All right, and arc sine of 5, there is no place where an angle that gives a sine of 5. You can't be bigger than 1 or smaller than negative 1. This has no solution. All right, so a few more complicated ones here, but we're just going to have the double. So this is asking when is the sine of pi over 6, and then it's asking for the inverse cosine of that place. All right, so let's see. So let's just work this out. Sine of pi over 6. So sine of pi over 6, let's see, pi over 6 has square root of 3 over 2 and 1/2. So this answer right here is 1/2. So I have a cosine, negative 1. The answer to this is 1/2. Now it's asking for when is the cosine 1/2? Well, the cosine is 1/2 at 60 degrees because the x value is 1/2 at 60 degrees. So this would be 60 degrees, or you could say pi over 3. All right, letter B. Arc sine -5. This is illegal. Same reason this was illegal. I can't do this, therefore I can't cross, these two things can't cancel, so this one actually has no solution. Over here, letter D, cosine, inverse cosine, and this is a legal question right here. So these just cross each other off, and the answer is -1/2. All right, and then letter C. So for letter C, I don't recognize the sign of radical 7/4 as being something off the unit circle, so that's why I give you a hint to draw a picture. So arc sine radical 7/4, that's going to be in the first quadrant, positive. So the sine is the opposite over the hypotenuse. So we're going to have to find the third side. So square the hypotenuse, so 16 equals radical 7 squared plus x squared. So take away 7, that's 9. So x squared equals 9, which means my answer is 3. Okay, now find the tangent of this picture, the tangent of this angle. So the tangent of this picture is radical 7/3. All right, so moving on, sine, cosine rule, we've just done recently. All right, and there's all the formulas there for you as well, and you need calculator or Desmos here. So find angle C. So I'm interested in this angle right here, so I'm going to be using my formula. I'm interested in angles, so I'm going to use this setup right here. So cosine of C is going to be, remember, these two pieces are the sides next to it. So I have 15 squared plus 10 squared minus the side across from it, 17 squared, over 2 times 15 and 10. Okay. And that's going to give me C. And let's go ahead and put that in my calculator. So cosine, hang on. So let me make a little fraction. Let me see, 15 squared plus 10 squared minus 17 squared over 2 times 15 times 10. All right, so that comes out to 3/25. So cosine C equals 3/25. And then I have to do inverse cosine to get my angle back. So second cosine of that answer is 83.1 degrees. All right, and so now that I know that this is 83.1 degrees, I can do my area. Remember, my area formula is 1/2 AB sine C. So my area is 1/2, I take the two sides, 15 times 10, and sine of the angle, 83.1. So put that into my calculator. 15 times 10, sine of 83.1. Or Desmos, and I get 74.5. And it looks like feet. So feet squared. So 74.5 feet squared. All right. So down here it says find the measure of the triangle pictured. Now recognize in number 13 we had to use cosine rule because it was side, side, side. I couldn't use sine rule because I didn't know an angle and a side across from it. Okay, but for number 14, I know 21 and I know this angle here. And so it's given to me angle, angle, side, so it's not ambiguous. I'm just going to go ahead and use sine rule. So 21 over the sine of 95 equals P over the sine of 32. All right, so when I solve for P, I'm going to have 21 times sine 32 divided by, P would be with sine 95, so that goes under here. All right, so 21 sine 32 divided by sine 95. That comes out to 11.2. And there's no units on there, so we'll just leave it at that. All right, now to the most horrible kind, the ambiguous case. You can tell because I was asking you all these answers here. So this is going to be angle, side, side, right? So I'm going to try and draw an angle that's 24 degrees, all right? And then across from it, so that's going to be my angle D, and then, I don't know, E and F anywhere. So D is 12, and F is over here, 16. All right, so you can see here, I got an angle, I got two sides, so that's not a bad word for us. So this is the ambiguous case. So I'm going to have to try for two triangles. It might work, it might not. So I do 12 over the sine of 24 degrees equals 16 over the sine of f. So when I solve for sine f, it's going to be 16 sine 24 divided by 12 would be next to sine f, so I'm going to divide by 12. So I'm going to do that, and then I'm going to do arc sine to get actually what f is. Okay, so 16 sine 24 divided by 12 gets me 0.542. I'm going to do arc sine of that answer, and then that's 32.8. So 32.8 degrees. So the alternate is always going to be, if it exists, 180 minus that 32.8 degrees. So 180 minus 32.8 comes out to 147.2. All right, so these are my settings for now. I'm getting f is 32.8 for my regular triangle, and alternately it could be 147.2. All right, so let's check it out. So 180 minus 24 minus 32.8 is 123.2, so there is one triangle. And if I do 180 minus 24 minus 147.2, comes out to 8.8, so there is a second triangle. So the only thing that's annoying about this is now I have to find e in both situations. All right, so I'm going to use my 12 over sine 24. That was given to me originally. I'm going to use to find e. So do e over the sine of 32.8, no, 123.2. And then the other way I do it is 12 over sine 24 equals e over this e, 8.8, sine 8.8. All right, so when you solve it out, let's see, this guy on the left, I got 12 sine of 123.2 divided by sine of 24. That comes out to 24.7 centimeters. And then for the other guy, I'm going to have 12 times the sine of 8.8 divided by the sine of 24. And that comes out to 4.5 centimeters. All right, so this last little bit right here, we're just going to find all these this information about these graphs and then be done. So let's, right here, this information right there, sine. So first when I look at this, I notice this 2 is inside. Take that out. So 3 sine, let's pull that 2 out, which leaves me x minus pi, and then plus 2. So it has a lot of transformations. The amplitude is 3. This 2 affects the period. So remember, 2 pi over 2 is going to be my period, so the period is pi. Vertical shift of up 2. This is to the right pi. And reflection, no, there's no negative in front. All right, over here on this cotangent graph, reflection, yes. Amplitude, there is no change right here, so we can say 1, but there's really no change in front. Vertical shift, yes, down 4. Horizontal shift, no, there's nothing with the x, so none. Period, the period of cotangent is normally pi. I have to divide that by the 1/3 in front. So that flips up and becomes 3 pi. All right, looking down here, my amplitude and period and all that. This is supposed to be a secant graph. So let's see, 2 is this high point, -4 is there. That's a distance of 6. So 3 up or 3 down puts me at a midline of -1. That means that this thing has shifted down 1. And since it's here and the height of it from -1, that's 1, 2, 3 spaces, so my amplitude is 3. Because, you know, half of the distance, half of the 6. All right, so the period. When I look at this problem, it looks like, so it's a pretty good marker to say from here, one down, one up to there. That's one full rotation. I have a downward and an upward parabola, so that goes to pi. Remember, the normal period of secant is 2 pi. So 2 pi over b has to come out to pi. Well, I can easily see that b has to be 2 for that, so my b has to be 2 to make this work. And I told you that it goes left pi over 4 to draw this. All right, so let's write the equation. Amplitude is 3. It's a secant graph. I have to have my b value of 2. Next, I'm going to the left, so plus pi over 4. And it goes down 1, so minus 1. So if you type that into Desmos, you'll get this picture as a check. All right, that is it. Come to office hours if you need some extra help. Bye.